First question in today's class is in reaction of this benzamide. This is benzamide group. So we have two reagents on arrow. First is alkali in presence of bromine and then benzoyl chloride. So whenever you have a amide group on reaction with the alkali and bromine, it undergo Hofmann bromide degradation. This is Hofmann bromamide degradation. So product formed here will be the degraded carbon, that CO will not be written in the product. Without CO you have to write the remaining structure. So it will be para-methyl aniline. So this will be the product formed on reaction of first reagent. Then second reagent is, this is benzoyl chloride. Its function is benzoylation. It will cause benzoylation. So this group will be attached, to electron rich center. Now electron rich center, we have two substituent present here in the ring. One is methyl and other is NH2 group, and this is more electron rich. So benzylation of this group will occur. So final product will be NH, then CO, and here will be benzene. How this happen? This is your pH, C double bond O and Cl. So this is electron rich and this is electron deficient. As this pi bond will migrate to this oxygen, it will acquire negative, it will acquire positive. So this will be attacked by nitrogens. There will be bonding between these two. So there will be formation of CH3, then benzene, then we have NH2, and one CO negative group is attached to it. On one side it has phenyl and other side it has chlorine group. Now nitrogen has donated its lone pair, so it will acquire positive, strong tendency to neutralize its charge. Similarly, this oxygen has strong tendency to neutralize its charge. And here we are observing one leaving group. Halogens are very good leaving groups. So first, how this nitrogen balances its charge? It will lose one H plus ions from here and will neutralize its charge. Similarly, this negative charge of oxygen will further come toward this oxygen. There will be formation of C double bond O and simultaneous removal of Cl from here. Means we can say that side product HCl is there. So we will left with this much part only with the neutralized charge. So this is the product form. This is benzoylation. So this cannot be the answer. This part must be there in your answer. So this is option number C. Now next question is, maximum number of isomers including stereoisomers are possible for monochlorination of this compound. You have to chlorinate once only, one chlorine atom, one hydrogen atom replacement by chlorine atom. So when you are forming chlorination here, so you are adding chlorine and you are removing hydrogen. Just count the number of types of hydrogen present here. So just consider the environment of different hydrogen present here. So this is one hydrogen which is directly bonded to this carbon. So it is one type, HA, let this be HA, and this is CH2. So let this hydrogen is HB and this hydrogen is HC. Okay, now this is hydrogen on left hand side. Let this be D and this is E and this is F. Now if we are drawing a plane, if we are cutting this molecule through this plane, so what will happen if we are using this plane? So what will happen? So this hydrogen is parallel to this side. This hydrogen is reflected by this hydrogen. So it means these hydrogens are equivalent. So if it is B, so we can put D is equal to B. So this is also B. This is C. The E is also is equal to C. Whereas F is not being reflected by any one of atom around it, but it is being bisected by the plane. So it is one type of hydrogen and A is another type of hydrogen. So total types of hydrogen, total types of hydrogen here is 4, A, B, C and D. This is A, B, C and F we have labeled. Okay, so 4 types of hydrogen. So 4 chlorine compound will form. So first possibility is formation of this chlorine compound. Let this be ethyl and replacement of hydrogen A first. So we will be getting this. Second time, what can be the product? Replace B by hydrogen chlorine. So we will be getting this type of product, hydrogen, and then it is CHCl, and here it is CH3. Okay, now on right hand side it is CH2 and CH3. Now third product, you can replace C hydrogen by a chlorine atom. So this is CH2, CH3, H and CH2, CH2 and Cl, and here we have CH3. And fourth, when you are replacing F, then we will be getting CH3Cl and CH2, CH3 and hydrogen, and CH2 and CH3. Now these are the structural isomers. So total number of isomers will be equal to total isomers will be equal to, it will be equal to total number of structural isomers plus total number of stereoisomers. Now further number of stereoisomers, structural isomers we are getting 4, plus stereoisomers will be geometrical isomers plus half of optical isomer. This is the formula you have to use. Now geometrical isomers can be cis trans, or this can be RS, such type of isomers can you have. So optical isomers, just check the chiral center here. So in out of these 4 structure, we have this first compound where carbon is attached to 2 similar atoms. So this is not chiral. Here structure number, this is, and this structure, is it chiral? No, it is not chiral. Is it chiral? Yes, it is chiral, because this carbon is attached to 4 different groups. 1, 2, this is different and this is different group. And in this case, this center, this is a chiral center. Again, it has 2 chiral center. In fact, 1, 2 chiral center it has. And then we have this compound where it has again similar groups attached, so it is not chiral. So for stereoisomers, we have to count the chiral compound present in the compound, in the product. So number of chiral compounds here are 1 and 2. In 2 compounds we are getting chiral centers. So they will show their own optical isomers. So total number of geometrical isomers will be 0 plus half of optical isomers. So as it is chiral, so obviously it will have 2 isomers, 2 enantiomers. So 2 will be of this carbon and 2 will be of this carbon. A total of 4 isomers we are getting from this side only, this compound only. Whereas in this compound, it has only 1 chiral center. So 2 isomers we will be getting from this compound. So 4 plus 2, 6. So 6. So we will be getting geometrical isomers. You have to take 1 because the compound itself has structure. That's why we are dividing this optical isomers by 2. So what will be the answer? 4 plus 1 plus 3. So answer is 8. So in this way you have to find that number of isomers formed. Next is, what is the major product formed during this reaction? So this is the reaction where we have written acetic anhydride. Acetic anhydride means acetyl group, and then anhydride as functional group. So this is your acetic anhydride. Its function is, it causes acetylation. If you have benzoic anhydride, then we should have benzene ring here, C6H5. So it will cause acetylation. It is a source of acetyl group. So acetyl group is electron deficient. It is electron deficient, and that's why it will attack on more electron rich center. Because there are 2 electron rich center, we have nitrogen in 2 places with 1 lone pair of electrons. Now in both the cases this nitrogen lone pair is involved in conjugation. That's why it is not available with the ring frequently with the nitrogen for donation. But this lone pair is not readily available because this is not in conjugation with the ring. There is one carbon with 2 hydrogen, so a gap of 2 sigma bond between the ring pi bond and lone pair. So it is not in conjugation. It is 100% available with the nitrogen, but it is not available. It is 50% available with the nitrogen. This center is more electron rich. Obviously, acylation will occur at this site only. So we can eliminate the options from here. This is correct option where one NH2 is intact and acylation occurred on the group present on side chain. So all other options are incorrect. So that's all for the day. Thank you so much.